Hi, this is your Chapter 10 video. We're going to talk about Chapter 10 about geometry. And really I want this video to serve as a quick review for you to go through right before the exam. So let's get started. So in this chapter, these are the 7 learning goals that we really focused on. So we talked about visualizing and mentally manipulating shapes. And remember, we did that with some blocks, spatial visualization, and we also did that with talking about the phases of the moon. We talked about understanding and applying angle measures. We talked about that through the parallel postulate, talking about parallel lines, through triangles and how triangles have 180 degrees and how we can prove that, the internal angle sum, and also straight lines and why we know and how we know that straight lines have an angle degree of 180 degrees. We also talked about the laws of reflection in the angle context to the real world. So we talked about the reason for the seasons and how angles play such a critical role in understanding that concept. We talked about defining circles and spheres and using those to solve problems. We talked about, and we practiced using a compass and a straight edge to construct angles, but also various polygons such as rhombuses and triangles. We talked about properties of polygons and then relationships within them. For example, that squares are also rectangles, even though that can be fairly confusing to kids. They're just special rectangles. And then, of course, we always talk about justifying our math reasoning, making sure that whatever we do, we talk about the why behind it and how we know that something is, in fact, true. And remember, that's a big piece of what we practice when we do our problems of the month. Okay, so let's get started. Remember, first of all, that geometry, when we talk about what is geometry, we're talking simply about the study of shapes and shapes in space. All right, so let's go ahead and start talking about our moon phases. So we know that geometry promotes our ability to visualize and manipulate spaces and objects in space. And so remember that when we talked about the moon phases, we talked about these different perspectives, that when you view the moon from space, so floating out in space, you're always going to see that half the moon is illuminated by the sun. But your perspective from Earth is quite a bit different, and that's how we see the phases, and that's why we see the phases. So if you can see here, I've correlated each of these phases of the moon, the last quarter new, first quarter and full, to each of the positions that you would see from space. And you can see that it's quite a bit different. Your perspectives make that different. But also remember, this is just a 2D representation of a 3-dimensional phenomena. And a lot of times people get confused when they learn about the moon phases. They don't understand why during every full moon we don't have a lunar eclipse. And that's because in most of our diagrams, we're always assuming that this plane, so like the surface of this board, is all the same for the sun, the earth, and the moon. And if that was the case, we would always have a lunar eclipse during a full moon. But it's not the case because the earth and the moon are not exactly in the same plane. And so as a result, we don't always have a lunar eclipse. In fact, they're fairly rare, but not nearly as rare as a solar eclipse. Also, I just want to talk about that definition of angle. And the reason that we used an angle ruler in class is because when you define angle as the amount of turn, it really makes sense to kids. It also really makes sense when you stand up and you actually turn your body and really think about an angle as literally that degree of turn that you make. We also talked about the parallel postulate, and basically we know that if we have parallel lines and a transverse line cutting through those parallel lines, that corresponding angles, as you can see here, are equal. And then we're able to, of course, apply that postulate in order to solve many angle problems. All right, so now let's talk about angle phenomena in the world. So we already talked about the moon phases, but it also applies in when we talk about the seasons. And we talked in class how this is one of the greatest misconceptions in science that's out there. And a lot of times this is because our diagrams in our textbooks show that the orbit around the sun, that's supposed to be the sun here, is an ellipse. Well, it's actually almost a perfect circle, but when it's drawn like this, a lot of times people will think that the cause of the seasons is because the Earth gets closer to the sun at certain times of the year. That's not the case at all. It all has to do, of course, with the tilt of the Earth at 23.5 degrees from perpendicular, and the tilt of the Earth towards the sun at certain times of the year. So you can see that here, the northern hemisphere, which would be up here, is tilted at this time of the year towards the sun, so you're getting the more direct rays. You're getting the rays that hit closer to a 90-degree angle, if you think of it that way in terms of direct. So those direct rays will give us our summer type weather. So the indirect rays, so down here, further from that 90 degrees, so you're still getting sun's rays, of course, down here, but you're getting those indirect rays, and that correlates to winter. So just also one thing to talk about is this other phenomena. Every time we look in the mirror, every time we use any type of reflective device, we know that light is coming in and it reflects off. And what it does is it reflects off at the same angle. So if it's a flat mirror, that's what happens. It comes in at a 60-degree angle and it reflects off at a 60-degree angle. And that's why flat mirrors are used for you in bathrooms and such. But in fun houses, you do not have flat mirrors, and so you see the different angles of reflection that occur from mirrors that aren't flat. All right, so now let's talk a little bit about circles and spheres. So all that we really are talking about at this point in terms of circles and spheres is that a circle is just simply a collection of points that are a fixed distance from the center. And if you think about taking a push pin and attaching a string to it, you put the push pin in the center, and then moving the string around, you would get a perfect circle. And every point along that circle, because you're pulling it tight against that string, they're all going to be a fixed perfect distance from that center. Circles are named by its radius. Sometimes they're also named by the diameter, which goes all the way through the center of the circle and through both sides. A sphere, of course, is very similar to a circle, except a circle we're talking about a shape that exists in a plane, whereas a sphere is a shape that exists in space. All right, and then lastly, we just want to talk about the correlation between rectangles, squares, and rhombuses. And so we think about the sets of these, and we know that squares here are also rectangles. They're also rectangles because rectangles, of course, have 4 sides. Opposite sides are the same, and they have 4 right angles. Well, that's the same with squares. Squares just happen to be special kinds of rectangles because all 4 sides are equal. It's the same with a rhombus. 4 sides are equal. It's just that rhombuses do not have right angles. So rhombuses and squares share characteristics, as do rectangles and squares. All right, and lastly, we're just going to talk about constructions and some of the basic constructions that you'll need to remember that we practiced. One is constructing a triangle in a circle. And how do you know that this is an isosceles triangle when you use a circle? So remember that by any given point outside the circle here, that's supposed to be a perfect circle, those are equidistant from the center. And so if we draw lines from the center, we know that this is a radius and this is a radius. So those are going to have the same measure. So at any points that we draw along that to make 2 points of the triangle, that will be an isosceles triangle based on our definition of a circle. Remember when you make an angle bisector that you have to make 2 points here, keep your compass at this length to make your arcs, and then bisect or cut that angle in half. You may also need to practice a perpendicular bisector, which is also using a compass to make a circle or just an arc that is this distance for the segment AB. And you'll notice that that arc or those circles will intersect in 2 points, which will cut and bisect, this becoming the midpoint of that line segment. And then also remember that if you're given dimensions of a triangle to build, that there are many different ways that you could do that, but just remember that one of your sides of your triangle has to always be less than the sum of the other 2 sides. So for example, this works because we know that 4 is less than 3 plus 2. Not every dimension or set of dimensions will work when building a triangle. Okay, so that's just a very quick review of Chapter 10. I hope that helps. You may want to go through that again just to make sure that you are clear on every single component ready for the exam. Thanks for listening.